classifier, a sentence level classifier that is most likely an LLM. And so why is that a problem, really? Well, in both cases, whether we're dealing with lexical constraints or semantic constraints, this is the expression that we're interested in. It's just saying, given the generation so far, y1 to I, does there exist a continuation such that the constraint is true? In the case of lexical constraints, we can do that efficiently, right? We can basically construct the circuit and we can explore the space of this exponentially many continuations to see which one of them satisfies the constraint and which one does not, and prune away tokens that lead to generations that violate the constraint. However, it's not really clear how to do that in the case of non-lexical constraints, right? Because what that would entail is that I would need to basically evaluate all possible completions, run them through the classifier, and get whether or not that satisfies the target attribute. So what can we do? Well, let's think step by step. So to begin with, we have a sequence level verifier, phi sub a, for our target attribute A. And what we want to do is we want to basically sample from this set of sentences that satisfy the attribute. If you rewrite the next token distribution and through some basic algebraic manipulations, you can forget about everything that is on the slide. Just know that what we're interested in is we're interested in computing this expectation that is shown in green. So this expectation, what it's saying is, I want, for all the possible continuations, I want to evaluate the classifier and see what the classifier is going to tell me on each of these continuations. Of course, this is hard, right? We'd like to be able to solve it. And we kind of have a piece of the puzzle, right? So we know how to compute expectations approximately of simple functions. So far, our simple function has been an indicator function. But what can we do when we have a neural network? This is a very hard problem. So one key insight is that we can approximate the verifier with a first order Taylor series. So by linearity of expectation, what we end up with is this algebraic expression. And the key part here is that